All right, everyone. Welcome to our study group session. Today, we're going to pop the hood on the Ethereum protocol and really get into its engine room, the execution layer clients.
Okay, so here's our plan of attack. First, we'll cover what the heck an execution layer client even is, the engine room, right? Then, we'll check out Geth, kind of the original blueprint. After that, we'll meet the challengers who came along and really shook things up. Then, we'll throw them all into the ring for a client showdown with some hard data, and we'll wrap up with how you can choose the right one for your own projects.
All right, Section 1, the Ethereum engine room. So first things first, let's get on the same page. What exactly is an execution layer client, or EL client? At its heart, an EL client is the software that actually runs the Ethereum virtual machine, the EVM. It's the piece of the puzzle that processes all the transactions and manages the state of the network, keeping track of all the account balances and smart contract data. And since the merge, it's got to work hand in hand with a consensus layer client. Basically, it's a transaction-driven state machine.
Yeah, here's a pretty good way to think about it. If Ethereum is this giant, global, decentralized computer, then the EL client is its operating system. Or you could even think of it as its CPU. It's the component that's doing all the heavy lifting, processing every single instruction, every smart contract call, every token transfer. Yep, that's going through an EL client.
Okay, so now we know what they are. Let's dig into how they're actually built. And you just can't talk about that without starting with the original, the big one, Geth. That's short for Go Ethereum, and it's pretty much the blueprint for everything that came after.
If you crack Geth open, it's really made of three fundamental parts, three main modules. You've got the computing part, which is the EVM itself. Then you have storage, which is basically a big key-value database they call ethdib. And finally, you've got networking, which is the piece that talks to all the other nodes on the network using the peer-to-peer protocol, Dev2P.
And check this out. This quote really hits the nail on the head. For those of us who actually like to dig into the code, if you go look at the eth/backend.go file in the Geth repo, you'll find this main Ethereum struct, and it's all laid out right there. The transaction pool, the database, the P2P server, it's literally the whole protocol abstracted into one neat package. Super cool stuff. But, of course, Geth isn't the whole story. As Ethereum got bigger, the network started running into new problems, right? Things like how long it takes to sync a node, and how much disk space and RAM you needed. This is where the challengers come in, each one with a new philosophy for how to build a better client. First up is Aragon. Now, Aragon actually started as a fork of Geth, but they introduced this killer innovation called staged sync. See, Geth kind of tries to do everything at once when it syncs. It's downloading blocks and replaying transactions all jumbled together. Aragon's team said, hold on, there's a better way. They broke the whole sync process down into separate, optimized stages. And man, that made a huge difference in efficiency.
So why is this so much faster? Well, it's actually pretty brilliant. Look at the steps. First, Aragon just focuses on downloading all the blocks. That's a heavy disk and network task, right? Then, once it has the data, it focuses on executing all the transactions. That's a heavy CPU task. By not making the CPU and the disk fight for resources at the same time, you avoid a massive bottleneck. This whole one-thing-at-a-time approach is the secret sauce behind its incredible sync speed.
But it's not just Aragon. We've got a couple other big innovators. There's Nethermind, which is this super robust client written in C# and .NET. So if you're working in a big enterprise, or you're just deep in that Microsoft ecosystem, this is a huge deal. And then there's the new kid on the block, Reeth. This one comes from the team at Paradigm, and it's written in Rust for performance and safety. The whole idea behind Reeth is modularity. They don't just want to build a client, they want to build an SDK, a toolkit, so that we can build our own custom high-performance nodes.
Okay, enough talk. How do these clients actually perform against each other out in the wild? It's time for the client showdown. Let's look at the numbers.
All right, check out this table. This gives us a really good snapshot of resource usage. First thing my eye goes to, database size. Look at Aragon. It's the slimmest by a good margin, just 1 terabyte. Reeth, on the other hand, is the hungriest for disk space right now, but it's still optimizing. Now, the RAM column is really interesting. For Aragon, it says OS Managed Cache. What that means is it basically tells the operating system, hey, use whatever free RAM you have to cache the database. On a machine that's dedicated to running the node, that can be a really, really efficient way to manage memory.
But wow. Okay, this chart right here tells the real story. The initial sync times. This is where Aragon just blows everyone else out of the water. 2 hours to sync a full node from scratch. That staged sync architecture we talked about, this is the payoff, right here.
Gath and Nethermind are respectable, around 5 hours or so. But Wreath, well, you can see it's still maturing. Syncing a node is currently a multi-day project.
So, with all this data in front of us, the million-dollar question is, how do you actually choose? As an engineer, as a staker, how do you match the right tool to the task?
Okay, let's boil it all down for the study group. Geth is your safe, battle-tested choice. It's the reference implementation for a reason. Aragon is for those who need to get up and running fast and want to save on disk space. Nethermind is a super solid, reliable, all-around performer, and Wreath is the forward-looking choice for you developers out there who want a highly modular SDK to build on top of.
And this is really why this all matters. There is no single best client. It all comes down to your engineering requirements. A home staker trying to minimize hardware costs is probably going to go with Aragon for its tiny disk footprint. An enterprise building on Azure would likely lean towards Nethermind for its sweet .NET integration. And a researcher prototyping a new EIP would find Wreath's modular SDK to be an absolute game changer. This diversity of clients is a huge strength for Ethereum.
So I'll leave you with this final question to think about. As you continue your own studies, consider which of these factors matters most for what you want to build. Is it raw performance? Is it architectural flexibility? Or is it proven battle-tested stability? The right answer depends entirely on what you're trying to achieve.